So then, Saul Henderson, are you ready to go?
Yeah, you can hear me?
Yes, we can. Okay. So now we have next Saul Henderson, advised by Dr. Sasan Hagani, XBee-based wireless sensor network for air quality monitoring in home office.
Alrighty, I'll start sharing. Okay. You can see my PowerPoint, right?
Yes, yes, we can.
All right, perfect. So, good afternoon, everybody. I'm Saul Henderson. Today, I'll be presenting on a wireless sensor network, air quality monitoring. Yeah, so it's going to be a wireless sensor network, air quality monitoring in the home office. So, I don't really consider this as a project. This is actually more of an adventure. It started off as a fun project that I thought I can do in one day, but it turned into a huge emotional roller coaster ride. So for the next 9 minutes, I'm going to try to illustrate what I've been through on this project. So everyone buckle up. So quick outline. We're going to go over the background, the objectives, the methodology, and then we're going to go over each system that I considered good for this wireless network. And then we're going to conclude and just go over the future work. So just a little bit of background. I think everyone knows my battle with COVID last year, not once, but twice. Okay. Um, this was not fun. Needless to say, I'm probably on medication for the rest of my life. Nevertheless, from now on, I have to be vigilant. What comes into my house, right? A lot of pollutants outside. There's a lot of gases moving around in the house, right? We're cooking a lot of things going on. So we have to track these patterns. So why not build a wireless sensor network that measures the gases, measures the pollutants, right? So this is a very long-term project. It's not over today. This is going to keep going, right? So we want to gather that data from sensors. We want to process it, analyze it, and we want to I guess, use some machine learning algorithms or however we need to do to make conclusions from that data and make better decisions. Of course, you can use common sense, but again, why not have fun? So I want to determine the best components for such a wireless network. All right. So the objectives for this network, we want to determine the relationship between human activity and gas levels. So we're going to start off with motion and gas levels. And there are many ways to do a wireless sensor network, but I chose three that stood out to me. So there's an XBee-based system where we rely on XBee modules to transmit data. And then there's the XBee Arduino-based system where we're adding the Arduino to the mix so that can take in data and process it. And then we're going to do something completely different, which is the Amazon Web Services based system that I kind of just came up with probably a few weeks ago. So I wanted to explore that. So I want to look at the network based on cost effectiveness, implementation, and data handling. So of course, it must be a cost component system because, as you know, students are broke. I'm no exception. The best system would ideally be easy for anyone to implement. I need to teach people how to do this. Okay. Lastly, the system must be reliable. All right. We need to transmit data, store it, and upload it to the cloud reliably. Right. So those are the objectives. So the method, we want to do the following. We want to gather data from end nodes. We want to use telecommunication devices to transmit the data to a coordinator or the cloud, and want to store and analyze that data. So to meet these requirements, I decided to look at the XBee modules, the Arduino Uno, a lot of gas sensors, and some data storage options. So just like I said in the last slide, I'm going to be evaluating this on cost, implementation, and the ability to handle data. So here's an overview of the components, just an in-depth list. So if we look to the left, we start with the microcontrollers. We have the Arduino Uno, the blue board, and then we have the ESP module, this black board that connects to Wi-Fi. And then when you look at the sensors up top on the left, you have the MQ2 and the MQ4, really cheap sensors that measure or approximate smoke and methane. And then you have the motion sensor, it's a digital sensor, okay? Then you have communication devices at the bottom left. Blue one is the XBee Series 2. The black one is the XBee Series 3. We can program the Series 3 XBee, which is cool. But what's not pictured is the power, which is the solar battery. That'll be powering the end nodes, which will collect the data from the house, right? So starting with the XBee system, you can see on the right, the XBee system is really simple. We're solely relying on the XBee to gather data from these sensors, which you see on this breadboard right here. So the XBee will gather data, the raw data, transmit that raw data to a coordinator. The coordinator will then log that data, and then we have to manually save that data from that log. And then we have to do all the pre-processing in Excel. And then we do all the data analysis in Python or R. So it seems pretty involved, but I could do it. I'm fine with that. So just a quick topology here. So the coordinator, it will create the network. It'll be sitting at my desk. The end nodes will be placed in different parts of my house. One at the door, probably the other one, the other one in the kitchen, near the stove, probably wherever safe. So that's the topology. And then this is just a screenshot of the XCTU software. This is the software used to program the XBees. So what we're seeing is that the coordinator node, or the node that's getting all the data, is displaying those 16-bit packets. So what's really important about these packets is that it holds that data from the sensors, which we need to read, which we need to save, which we need to use to analyze the data. That's very important, right? So I'm feeling pretty good about this first part. Now here's where the emotions start happening, because I really thought this was great. So the good part and the bad part. So the good part is that the XBee Series 2 modules, those blue modules I've shown you, they're really easy to use. So I'm just kind of like, yes, easy to use. Give me the data. And then XP3 modules add on to that, because now I can program those modules. That's more functionality for me. XCTU has everything I need, but here's the bad part, right? I found this out the hard way. The XBee series, they only read raw analog data. That's meaningless, right? Usually when you gather data from a sensor, you usually get that raw ADC reading. You need to convert that to something like parts per million or something. XBee cannot do that. Most low-cost power sensors, they usually need coding libraries to extract the meaningful information like parts per million, stuff like that. XBee cannot do that. XBee3 is a programmable. I was excited about it until I found out that the MicroPython terminal is not friendly. All right, you can write 30 lines of code and it'll tell you made a mistake. It won't tell you that. You have to manually do it all over again. I spent 2 hours on this. I spent $200 on these systems. I'm out $200. Not mad at all. So we're going to move on to the next one. The XBee Arduino system. So this is just like the XBee system, right? Except we're now using the Arduino under here, not only just for power, but now we're using the Arduino to actually read the data from the sensors, and then also use the libraries to extract the meaningful data from those raw data readings. So instead of just an ADC reading, we can now use Arduino to say parts per million. And once we do that, we use the XBees to transmit that data to the coordinator. So that's really what this system is, right? So this slide is really just me kind of like testing, debugging the ability for the coordinator node to receive the data packet in Arduino. So the Arduino lets me know, all right, you received the packet, nothing more. I just wanted to see how far I can go with this. So no problems with the coordinator here. So again, a little more happier, right? This is working, but again, here comes reality. I found out, again, the hard way, I cannot program the XBee to get that useful data using the Arduino IDE. I can only use XCTU. That means I cannot use the Arduino's ability to transform that raw data into meaningful data. Historically, Arduino users had trouble trying to use the XBee, to communicate with each other using the Arduino IDE. Wow. So now at this point, I'm out $350. I'm sad. I taught a bunch of students how to do this. I feel like a fraud. What do you do now? So again, and plus keep in mind I'm sick. So now, if it hadn't been for Dr. Agani, I probably would not have come across this, the Amazon Web Services, right? So instead of using XBee and Arduino, why not use a board that connects to the internet? Why not use a board that can use Arduino? Why not use a board that can also read the data from the sensors and then upload it to the cloud? Voila, Amazon Web Services, the ESP modules, right? So this may be a huge solution to the other previous two, I guess, failures, right? I'm gonna call it failures, okay? We live and we learn, right? So again, this is in the works, but this is just an idea of what's going on with the current iteration of this gas monitoring system, this network. So we see the users here. Let's just replace users with end nodes, the sensor data, right? So using AWS services, we can upload the data to a table, which is DynamoDB, and then we can store that data long-term using S3 applications on AWS. And then we can use SageMaker. SageMaker, this is a very heavy app. Okay, thank you. This is a really heavy app. So it has machine learning capabilities here. And then we can create a model which can make numerical predictions of the gas data in the house. So that's the AWS workflow there. And that's what I'm working on. So the good, I'm going to totally use this as opposed to Arduino and XBee because it has everything I need. This system only costs about $40 as opposed to the $350 for the other two. You really have to know what you're doing with the ESP modules. You have to know the difference between these two. You really have to know what you're doing in AWS because it does cost money to use their services. So you have to plan first, work fast, and know what you're doing there. And plus, if I do this project, I have more of a chance of getting a job because people want to know about AWS. So really quickly, lessons learned. These gas sensors are useless. MQ sensors I use are trash. They're unreliable. They're cheap. The higher end sensors are also garbage too. If you're doing a gas sensor project using the Arduino, don't do it. The XBees are great for communications project, but they're trash when it comes to gas sensor projects. Don't use them. I'm just being honest. Don't do it. If you want to do a gas sensor project, use the ESP32 module. Use a cloud-based service. Not only will you learn more, but you'll most likely get a job from that. Okay. So future work, we're going to continue on the ESP32 AWS path. It's the only way, optimal way. I'm all for it. So that's my presentation. It's all out.
Thank you, Saul. That's a very interesting presentation. And I also like the way, I mean, science and engineering development is done by people, and you took us on the human journey as well, which is really, really moving. Thank you.
No problem.
Any questions?
Yes, hi, it's me, Phil. I have a question, Saul. Way back when, I've also used the XBee modules. There's a project at another university, Howard, where we were using some thermal grid eye sensors. So what we ended up doing, we used an Arduino, we used the XBee, but we also used a software by the name of Processing, which was able to take the raw data from the XBee as it transmitted it from the Arduino and the sensor location to the notebook computer, and we were able to do some imaging of that sensor. Have you ever considered using processing for that?
I've actually never heard of it, but there are like metrics here as to the software I chose. So the first one is teachability. The second one is availability. So teachability, if it's a friendly, IDE that I can learn quickly and I can teach other students, yeah, I can do it. And as far as availability, it's free and students can access it. That's also not a problem at all. So that definitely sounds like a huge option there.
Well, yes. To answer your question about the teachability and the availability, if I can learn it in about, an hour, you can probably do a lot more than I can do with it. But yes, it's all those things and then some. You could go online, just look at processing.org, and and the software is readily available for download, and it interfaces great with the Arduino.
Yes, I definitely will take a look at that because again, I don't want to give up hope on these XPs. I'm gonna try to,
Yeah, I understand.
a lot of money here.
Yeah. All right. Good luck.
Hey, appreciate it.